Now, quite often in classes, when an instructor is trying to help you understand Transact SQL, you see these simple little SQL statements, right? Select asterisk from person dot person, and the very simple statements. And that's great. It helps you understand. But now let's kick it up a step and talk a little bit more about the real world in a video entitled Understanding Joins. Now, a join is a type of a query. It's a select query that retrieves data from more than one table. Now, data gets distributed across multiple tables because of something called normalization. Now, if you're familiar with that term normalization, then you're okay here. You're ready to go. If you're not, then let's back up right here just a moment for the folks who may be new here or kind of new to this whole database world and talk about what exactly normalization is. Normalization is nothing more than a design methodology of a way of organizing tables and the columns and the data in those tables to minimize redundancy and dependency on the data. Now, notice I left out that word relational because I wanted to explain that a relational database is a database designed on this whole normalization structure or normalization foundation. We're going to have multiple tables out there storing our data. And the data is all related to each other. And there's some sort of relationship that we're going to establish between those tables that, number one, the SQL Server database engine is going to maintain those relationships. And it's going to restrict us in some of the things we can do with that data in those multiple tables to protect the integrity of that data. And for us, it's going to make data management and storage much more efficient. Again, it's going to minimize redundancy and dependency on the structure of the data within the tables. We'll get into more of that later on, or you can go out and read about it. However, it makes retrieving data just a bit more challenging because now we have to join multiple tables to get at the data that we need. And in the real world, you will find yourself mostly doing joins. As a matter of fact, you'll find yourself joining 7, 8, 9, 10, 12, 13, 14 tables. Not unusual out there in the real world, but if you take it step at a time, it's very easy. Now, redundant data is always a problem. Notice we've got this nice little table here. Let's say that we're designing a database or operating a database for an insurance company. So you notice here, Harry Smith is 23 and Harry has purchased an automobile policy and this is his zip code. Angela James is 34. She's purchased an auto policy. This is her zip code. Frank Hornsby's 43. He purchased an auto policy and his zip's 37064. But Frank's the kind of customer we like. He calls back and says, hey, do you guys do boats? And we say, yeah. So Frank Hornsby, 43, purchases a boat policy. And look at his zip code. Then he calls us back. He's a really good customer. He just bought a motorcycle and says, do you guys cover motorcycles? Absolutely. Notice what's happened to our database. We're storing the same data redundantly. We're storing Frank Hornsby 43 3 times. We're storing 37064 3 times. It's going to be very possible to come in here and update one of these rows and not update the other. And now we have a lack of data integrity. We're storing all that extra data just so that we can actually store auto, boat, and MC for motorcycle, right? Well, let's talk about how we can use normalization to correct this problem. Again, the process of organizing data in separate tables. Notice what we've done. We've changed the table structure up a little bit. You'll notice we've added a new column, a CID column, a customer ID column to both tables. And now every unique customer, we store their first and last name, their age, and their zip code, right? And then we put CID numbers out here. Then in a separate table with CID numbers, notice we put the policies that they've bought. Now notice how easy it is to store the fact that Frank Hornsby, whose CID number 3, has purchased auto, boat, and motorcycle coverage. Okay, notice we got 3 3s here. Now, the way we have to treat this data to maintain integrity and to be able to query it is to connect these two tables based on that common column. And you'll notice that in our main table, the CID usually is our primary key. And in the connected table, it's called the foreign key. So this is a primary foreign key relationship between the two tables. Now, the SQL database engine is going to do a certain few things. Number one, we cannot delete this row that has Frank Hornsby out of this table unless we first delete these, because we're going to leave data over here that has no meaning to our database if we delete this row right here of Frank Hornsby. Also, I can't add a CID4 over here if I don't have a CID4 over here to relate it back to. So it's going to make sure that we maintain our data integrity. However, now if I want to retrieve the policyholder's name and policy type, I now have to do a join query between these two tables. We'll take a look at that a little bit later on. Now, there are three types of join queries that we can do. There's inner, and this displays only the rows that have a match in both join tables, and we'll demo these a little later. An outer join includes rows from one or both of the tables, even if they don't have related rows in the join table. And there's three types of these. There's a left outer. It'll return all the rows in the left and only the matches in the right. A right outer returns all the rows in the right, only the matches in the left. A full outer returns all rows in all join tables. And you're thinking, why would I want to do these? Just hang on, you'll look at demos a little later. Then there's a cross join. This includes one row for each possible pairing of rows from each table. This is a Cartesian result. We'll take a look at it later. But that's the basic of joins. That's how we got to joins. And coming up in the next video or so, we'll look at the query structure for a join query. So join me there.